In this video, I will talk about architectures for user interface code that overcome some of the limitations of JSP. In particular, I'll look at what are called the JSP Model 1 and JSP Model 2 architectures. Model 1 and Model 2 describe different ways of combining Java server pages, servlets, and Java classes. Don't worry much about the names. The names are just a quirk relating to the order they were described in an early JSP specification. Model 1 refers to an ordinary Java server pages application. JSP pages are the boss, and when you make a request, the JSP page handles the information and returns the result. The JSP page combines HTML with embedded Java. So, a simple JSP page could be described as following a Model 1 architecture. However, this basic Model 1 architecture can be refined. The JSP page can be kept on top as the boss, but rather than mixing the HTML and Java, we can separate the two. We can move the Java into a class of its own, and then call that class from the HTML. This improves the separation between HTML and Java, and this is still called the Model 1 architecture, but it's slightly improved. So here's a sequence diagram that shows the Model 1 scenario. A request comes in to the JSP view. The view then updates the state of a Java class, and the Java code does some computation. When this code completes, the view then generates a response by getting values from the Java code as appropriate. So again, all the heavy calculation is done in a Java class, but the JSP is responsible just for extracting the result from the Java and generating HTML. Now, a Model 2 architecture is the opposite. In a Model 2 architecture, the Java code is the boss. When you make a request, it's handled by a Java class. When it's finished, it uses JSP to generate the response. Here's a sequence diagram that shows the Model 2 scenario. A HTTP GET request comes in, and it's directed to a Java class. How does the server know which class to use? Well, the way to solve that is to make your Java class a servlet. Okay, so a HTTP request comes in, and it gets handled by a servlet. The servlet does any necessary processing, updating the database, and so on. Once it's complete, it forwards the data to a JSP page to generate the output. The JSP creates a HTML page and returns the HTML. So again, all the heavy calculation is done inside a Java servlet, while the JSP is responsible just for the HTML generation. In the sequence diagram, when control is passed from the servlet to the JSP page, data is passed along. But how is this done? Well, it can be set using internal page properties. However, this architecture, this Model 2 architecture, can be refined and improved in what is known as an MVC, or Model View Controller architecture. In an MVC architecture, the servlet that handles the incoming request is known as a controller. The JSP page that generates the output is known as the view. And in an MVC architecture, we refer to that data that is exchanged between the two as something special, as the model. The model is supposed to represent the internal conceptual understanding of the user interface. The model contains all the high-level logic. The controller should be as simple as possible. It translates incoming HTTP requests into appropriate operations on the model. Similarly, the view should also be as simple as possible. It should read from the model and generate an appropriate user interface. So here's a sequence diagram showing how the MVC architecture works. When a HTTP request comes in, the controller extracts any form values and then sets the model accordingly. It also figures out what operation to perform on the model. Then it passes control to a JSP page, which then retrieves information out of the model and generates a HTML response. I agree, this does look more complicated than a simple JSP page. However, by separating our code into different roles and responsibilities, the application now becomes more maintainable. We can give our views to the graphic designers, and we can give controllers to a servlet developer. We can implement the model according to the business or application requirements. Our JSP pages will contain no Java code, so they should be easy to verify. Our servlets and model will have no HTML, so they can be compiled and checked separately. And we'll have improved the separation and design of our code. Now, I've been speaking at a very high level, but how do these concepts translate down into working code? Well, we need to look at a few tools that make this possible. JSP Java Beans integration allows you to create Java objects from JSP pages. Expression language allows you to read properties of Java objects from JSP pages. And the request dispatcher allows you to pass control from a servlet to a JSP page. So in other words, it allows your controller to pass control to a view. In addition, JSP includes standard and custom tag libraries that allow you to write loops and conditional code in your HTML while ensuring that the generated HTML is valid. So here's an example of a counter application written using a Model 1 architecture. I've used Java Beans integration and expression language. The JSP useBean tag tells JSP to use a Java Bean. Java Bean is just a technical word for a Java class that has getters and setters and a default constructor. This useBean tag tells JSP to create an instance of the counter class and then use that instance across the entire application. Then, inside the HTML, the current value of the counter is inserted using expression language. This is the bit inside the $ curly braces. This expression gets translated into a getCount method call on the counter object. With Java Beans integration, you can create objects using JSP useBean. You can also set properties of that bean using JSP set property. Here, it calls setCount using the new count form parameter. Then expression language is used to retrieve the properties of the Java Beans. Expression language is a powerful language designed to be inserted into HTML pages. The language is inspired by JavaScript and is designed to allow you to write expressions in HTML without using any special characters that interfere with HTML editing. I've got a whole lot of examples up here. Feel free to study the slide or even download the full expression language specification. Now, Java Beans integration and expression language is enough for Model 1, but what about Model 2? Remember that in Model 2, we need some way of passing control from a servlet to the JSP page. Here's an example of a counter application written in a Model 2 architecture. Note that the servlet forwards control to a JSP page using the request dispatcher. And this is all it takes to make a Model 2 application. The servlet does its computation, it sets the result in the request attribute, and then it passes control to the JSP page using request dispatcher. From the request dispatcher, those attribute values can be read using expression language. Finally, what happens if you want to use loops or conditions inside your JSP? As we've already seen, you can embed Java inside JSP, but this is difficult to verify for correctness. So instead, JSP provides a standard tag library that's designed for compatibility with expression language and also ensures that any HTML that gets generated is valid HTML. You don't need to use the JSP standard tag library in this subject, but you should be aware of it. Okay, so to conclude, in Model 1, the Java server pages are the boss, but they can use Java Beans integration to pass control to a Java class. In Model 2, the servlet's on top. The servlet receives and processes requests, perhaps with the help of some model classes in the case of an MVC architecture, and it passes control to a JSP page to render the view. Which you use will depend on the situation. Model 1 is simpler and makes the most sense for an application that's mostly about user interface. Model 2 is more powerful and results in a better separation of your code, so it'd be preferred for more serious application development. Now, as you start using Java server pages, I'd like to think about how you're separating functionality from design. Does your code improve when you separate the two? Does it make your code more maintainable? And how difficult is it to achieve? Also, I'd like you to try to notice whenever you write similar code more than once. Soon, I'll be talking about more advanced approaches to web development that can further help simplify web development and reduce code duplication.